In this series of mini tutorials, we'll try to very quickly get started on important data science technology, such as pandas, which will be covered in this video. For more detailed information, we also publish pandas cheat sheet on our Medium blog post, and you can check that out. I'll link to it below. So real quick about pandas. Pandas has been invented by people in the financial sector, actually. When you cross over great financial analysts as well as coders, you get the technology that revolutionize data preparation work. Pandas has a misleading name. Unfortunately, it doesn't have anything to do with a cute animal. It's great for displaying structured data as opposed to unstructured data, such as images and files. So it's really good for things that look really nice in Excel tables or any kind of tables or Google Sheets. Generally, it's a very organized. It's a rectangle of columns and row data, and we'll see a little bit of that. But what's really nice, Pandas lets you query this table very nicely and slice and dice it so it will fit your data science needs. We'll take a very quick preview of that today and see the power of Pandas and how it can help with your workflow. So now I'm sharing my Chrome screen. So generally, I use this technology by Google called Google Collabs. It's Collab at research@google.com. This is essentially a Jupyter notebook in the cloud, very shareable, viewable, and easy to edit, just like other Google documents. It does provide you with some great CPU as well as GPU access, which we can definitely talk about in a future tutorial. When you visit this link, you can go ahead and click on New Notebook to view, to start to edit your data science environment. Google generally try to warn you when you open someone else's notebook and say, don't run the codes, it might harm your computer. And we say the same as well. In general, our tutorials are used for personal education purpose only, and we're not responsible for any issues that may come, may result as maybe a result of you following such tutorial. So please keep that in mind and refer to our disclaimer article as well as video for more details. So usually, there are two types of cells in this Google Colab. One is text cell, which you will use Markdown to display information, such as this. And another one is code cell. And you can like change that fairly easily. So I will say you can definitely start to organizing your code or text documentation a little better. So the first step, I always like to say installation, which is the dependency that we require today, just pandas and usually a little bit of NumPy. So let's just say dependency, both pandas as well as NumPy. And there's a little bit of convention to import these. So import pandas as PD. So that's the alias we'll be using throughout the notebook, and import NumPy as NP. And that's pretty standard. I pressed Shift Enter or Shift Return to run this cell, or you can press this arrow here. And now we have both libraries ready to go. So when I create a table, in Pandas, I have a backup notebook here on the next window available just in case we need to refer to it. So usually I would like to think about Pandas object-oriented programming as organizing two ways. Each of a Panda table is called a data frame. And each of the data frame, so that's sort of like equivalent of calling it tables. And then each data frame, so DF for short, that's also a convention, contains a series, one or more series. And series is a column. I would say it's like a column, like a feature column a column of data. So we'll see a little bit of that in play. And here we just create a little extra line so it looks nicer. Here we go. And I can start with the empty data frame. This is just saying, have a container, have a wrapper for my data. I know it will look something like a data frame, like a table, but I'm not filling it in yet. So that should return nothing. Once I start to add column data, I can say, okay, column data is, so the first column, let's give it a name, like month, okay? So, and then I will provide it with a list of like month. So January, February, let's just keep it simple to just use number. 1, 2, 3, 4, 5, 6, you get the idea. And I want to wrap this using Pandas series to turn it into a column. And now if I display this again, not only every row has an index, the column also has a header now. And in the future, I can use dot notation to access that column data, and it will always come with the index data too. Pandas, being a great data science tool, also tells you the data type of each of the cells. And what's really cool in Pandas is you can start to narrow down this data. You can say, okay, find me the row where the month equals to 3. And you want to use this particular notation. And this will basically, it's a binary, it's sort of a Boolean table and allow you to query your data frame. So you want to say data frame, square bracket to, and I want to include some condition in the square bracket that each cell will display to true. And I'll use this df, the column I want to query, and a double equal sign equal to the value I want to query. So there's just a brief like plural form. Just want to make sure we type the same, because everything is surrounding double quotes. We want it to be exactly the same. So you can see only this row comes back. And now if we added more data to this data frame, we can add sort of the English abbreviation of these months, right? So we can say, okay, just English language abbreviation. Once again, I want to wrap this list of data I want to provide to it with the pandas series object. And here I will have January, Feb, and March, April, May, and finally June. Now my table has 2 columns of data. You can also use describe to quickly get some stats on your data. This is not very useful right now because our markup data is pretty simplistic and they're mostly a lookup. But once you have more data that are numeric data, you can get mean, standard deviation, and minimum and maximum in the quantiles fairly quickly. Cool. And so we went over quite a few of these. You can store all kinds of data in your pandas data frame, and it's very useful to query. You can query further too. And earlier we just query by month, but now you can query by the first column as well as the second column. And then you can potentially try to set it, but this is a good error message to show you that Pandas does not prefer and does not allow this way of setting, because you're just working on a copy of the data frame. That is not, Pandas kind of predicted that's not what you want. So it asks you to use this format, which is a method it provides, an API called .lock. And what you will provide is the row indexer as well as a column indexer. So if I want to, for example, start changing the names up, I want to change it into the English name for each month instead of just of the abbreviation. What I want to do is I lock the first row, which starts with 0, and then I want to provide the column, and I want to say January. 2 things will happen. If you go back to the data frame, things have changed. So you don't have to restore. You don't have to do df equals to this. So, and then you can easily loop through it. So it's kind of nice. The first argument, you can have a Python range to increase it from 0 to 5, which will cover the first 6 entries and update your data programmatically. A very commonly used method in machine learning in particular is the dot drop method, which will drop a column. So for example, I can provide it with column equals to unexpected columns, I think. Yes, it's just a little bit of reading the documentation, Google Pandas documentation. It should come up. I think Pandas fall under the PyData realm right now. So, but notice there are some operations that are in place and some operations that work on a copy and returns a copy of the data frame. This is the example where the drop only happens to that instance, that copy of data frame. Your original data did not change. So you can always say, you can create a new data frame, such as like new equals to this. This way you always keep a golden copy of your data, and your original df does not change, or you can change this variable to df and replace your original data once for good. Cool. And why might this be useful? Well, one of the reasons why it is useful is also one of the reasons why that is useful, the drop column thing is useful, is that in machine learning, especially when you are trying to make a prediction on structured data, generally it's useful to choose one of the columns as a final label, the ground truth you want to predict. And you do not want to include that column in your features table. So you would drop that column. Just make sure your model cannot cheat on input data. Cool. 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 We talked about briefly some of the quick stats you can get from your data frame, such as using this. Okay. And then also you can definitely do the D type part. D types should tell you the data type of each column. That's nice, especially for computationally intensive data set. You may want to modify sometimes the data type and make it easier to compute. And then you can also do what's called value counts. In this particular data set, it's not very useful, but when you have data that has duplication and you want to aggregate, start to count the number of records per subgroups, it's going to be very, very useful. We will cover the aggregation methods using pandas aggregation methods in a later video to keep the video length manageable. One of the perhaps most often used method in pandas when you start it is the pandas read CSV method. You can provide a CSV file if you're running Jupyter Notebook locally, or a URL that links to a CSV file. In this case, you can see this is an example. And what happens here is that this CSV file happens to be hosted on GitHub. It does not belong to me. I'm just using it as an example. When you go to your GitHub repo, if you're starting a repo with a CSV file available, you want to click on that raw button to actually see the raw CSV file. Otherwise, if you're just linked to the page you're viewing it, it's a web page. and Pandas would not be able to parse that. It has to parse a CSV file. If I store this as a new data frame, this is a much larger file. And if I do df2.describe, I happen to give it a variable name. And we can see now things are much more, the summary stats become more useful. There's a large number of records. There are 3,000 records each. And we would be somewhat able to tell from this, but it's still a little hard. Min of each column and some statistics around that column. And we can also do the describe. Oh, sorry, we already did that, which is I'll do the D types. Cool. Mostly float, some objects, and some as well as integer. And we can also do, what else we can do? Do two.value counts. And this should give us some kind of like the unique, so the value counts, here we can look that up, value counts documentation. This is very frequently used. Return a series contain counts of unique values. As you can see here, not all columns, this is not a useful analysis on all columns because some of these, such as longitude and latitude, are continuous data. So that's not going to be very helpful at all because essentially every number has potential to be unique. But if we do the country column, this will start to be somewhat interesting. And if I do just counts, seems like it is still not aggregating. But if I run the method on this, I can say, okay, this data set does not include all the countries in Africa, but instead just focus on this 1, 2, 3, 4, 5 countries. So this is just a preview of what Pandas can do. As you can see, it's very powerful. I think just a few years back, before Pandas got really popular, this was quite hard to do, right? You have to hire an analyst who sit in a room, spend quite a few hours to wrangle the data. But now it comes pre-built, very Pythonic, easy to use. So do check out our article about Pandas cheat sheet and let us know if there is a function or method you would like us to cover. And real quick for our interns, you've seen that like one of the tasks you have to do is to combine data sets from different data sources. And one of the things you can think about is that you're really trying to fill out, when you're trying to combine two data sources, you're trying to eventually fill out this master table. And it starts as an empty data frame. You're trying to combine column features from each of these data sets together into this master table. You might see some duplications. For example, if you have lots of data points for a country, you might see the country name duplicated many times. Such was the reality of structured data. It does tend to have this kind of duplications. And in traditional relationship-based database, you will see more repetition compared to NoSQL database, where these repetitive parts can just be the keyword and everything else can be nested underneath this keyword, nested. So, but obviously, relationship database try to denormalize it, relationship database try to keep it dry as well, try to also remove a lot of duplication. But what's really cool is that Pandas are relatively fast and easy to parallelize. So some of these old problems that were bringing pain to data analysts and data scientists back then may no longer be as much of a pain now. In a future episode, we will also cover Google Cloud BigQuery, and we can see how Google Cloud manipulate a huge amount of data that's structured in tables really fast and be able to do really cool things on it. So when When you start to combine data sets, you might be adding columns and changing column numbers, the value in each column cells. And you can definitely talk to me about that one-on-one, and we can go over that. You might be adding new columns. So sometimes after you, when you're just concatenating different data sets together, you might want to do some aggregation and post-processing after that. And that may be the final result you're trying to predict using the machine learning model. So when you do some aggregation, some calculation on your raw data and end up with some kind of aggregation, you might be doing a really cool machine learning task, which is feature engineering. So you're creating your own feature columns after a certain processing. So that's really cool. So I hope you definitely take that step, start to combine data sets and complete data sets and create your own useful feature column.